All right, so we're going to solve this inequality, and we have, I broke down the steps here. First, we're going to cube both sides, okay? So we're going to cube both sides. There could be certainly more than one way to do this. This is just what I thought was the most direct way to do it. And then I have x cubed over x, because cube root x and x cubed are inverse functions, so they just leave you with x. And if I do 0.1 cubed, I get 0.001. All right, now what I'd like to do is reduce this. In this step, it says simplify to obtain the inequality x squared. All right, x squared is less than 0.001. So I'm going to reduce the x cubed and the x. So this is where it really comes into play that x is greater than 0. So in other words, I want to reduce this and say this is x squared. But I have this problem that I keep having where if I reduce an x, I can only do that if the thing I'm reducing is not 0. And typically, I actually want it to be at x equals 0, right? That's what the point I'm looking at is x equals 0, all right? But in solving this inequality, I can do this reducing because the x is not greater than 0. And how do I know the x is not greater than 0? Because x is greater than 0 because it says that right up here. Now, so this is all actually very important because it's saying how the distance from x to our limit point c is less than delta, but it's also greater than 0. So this pertains to the definition of the limit that you find in the book. Remember when we looked at the definition in the book? And you see this 0 is less than x minus c. We're going to come back to this a lot, that the x cannot equal the c in the limit statement. So when we're looking at the definition of the limit, the x is not equal to the c. The x is any number that is as close as you want to c, but not c. That's why it says when they write it out in words here that f of x, the values of the function, approach or equal L, but the values of x approach but do not equal c. So this greater than 0 is what makes this happen, which makes this happen, which allows us to do this. And that's really what the limit is going to do a lot of times, is let us to reduce a fraction that we wouldn't be able to reduce otherwise, because we're not looking at the point where where this fraction would be undefined at x equals 0. We're looking at every point nearby. So then we have this point 001, and then it says solve by graphing. Oh, so I've lost my place here, of course. Oh. Here's my paper that I'm actually working on. Pardon me while we experience brief technical difficulties. I've totally lost the paper that I was using. Okay, I'll find the paper and we'll continue from here.